Have you ever used one of those instant hand warmers and just wondered where all that heat is coming from? It feels like magic, right? Well, today we're going to dive into the awesome chemistry that makes it all happen.
I mean, really think about it. You take this little packet, you crack that disc inside, or just shake it up, and boom, it gets hot. There's no fire, you didn't plug it in, so where is that heat coming from? It almost feels like it's appearing out of thin air. How is that even possible?
Well, the answer to that little mystery, that free heat, it all comes down to a special kind of chemical reaction. And what's wild is that this kind of reaction is happening all around us, all the time.
And you know, the first clue to cracking this code is hidden right there in the name for it. We're talking about something called an exothermic reaction.
Okay, so let's break that word down. Exothermic. It's actually pretty simple. It comes from two Greek words, exo, which means outside, and thermic, which, you guess it, means heat. So put them together and it literally means outside heat.
And that's exactly what's happening. The reaction is releasing heat to the outside. It's pushing that energy out into its surroundings. And of course, that's why everything around it starts to feel warmer.
Okay, so it's releasing heat. But where does that heat actually come from in the first place? Well, the real secret, the engine behind all of this, is hidden inside chemical bonds.
So, here's how it works. Every single chemical reaction is basically an energy transaction. First, you have to put some energy in to break the old chemical bonds apart. Think of it like an investment. But then, and this is the cool part, when new bonds are formed, energy gets released. And in an exothermic reaction, the amount of energy you get back is way bigger than what you put in. You end up with all this extra energy.
So, what happens to all that leftover energy? Well, it's got to go somewhere, right? It gets released out into the world. Most of the time, we feel it as heat. But it's not always just heat. Think about a campfire. That's a huge exothermic reaction. You feel the heat, sure, but you also see the light from the flames, and you can even hear the sound of the wood crackling. All of that is released energy.
Here's another way to think about it that I really like. Imagine a ball sitting at the top of a hill. It's got a lot of potential energy stored up, right? The starting chemicals, or reactants, are kind of like that ball. The reaction is like giving the ball a little nudge. It rolls downhill, releasing all that energy as it goes, and ends up at the bottom in a much more stable, lower energy state. That released energy is the heat we feel.
Okay, so that's the science behind it. Now for the fun part. Let's look at where you can actually see these reactions in action. And trust me, once you start looking, you'll see them absolutely everywhere.
All right, example number 1, combustion. This is the big one, the classic. Anytime you see something burning, a campfire, a candle, even the gasoline in your car's engine, that is a massive, powerful exothermic reaction, just letting loose a ton of heat and light. And hey, let's go back to our original mystery, the hand warmers. So what's actually happening inside that little pouch? It's surprisingly simple. It's filled with a really fine iron powder. The second you rip open the package, oxygen from the air rushes in and starts reacting with that iron. It's basically just a very, very fast, controlled rusting process. And that reaction releases a nice, steady heat that keeps your hands toasty.
Okay, but here's my favorite example, and it might be the most surprising one of all. It's you, right now. Your own body is basically a walking, talking exothermic machine. The process that turns your lunch into energy, it's called cellular respiration, is just one big, constant exothermic reaction. It's what keeps your body warm and literally powers every single thing you do. How cool is that?
So, we've seen some cool examples, but why is this concept so important? Well, to really get the big picture, it helps to look at its polar opposite. Yeah, so the opposite of exothermic is endothermic. They're two sides of the same chemical coin. Exothermic releases heat, making the surroundings feel warm. Endothermic does the exact opposite. It actually sucks in heat from its surroundings, which is why it makes things around it feel cold. You know those instant cold packs you use for an injury? That's a perfect example of an endothermic reaction at work.
When you step back and look at it, it's clear that exothermic reactions are absolutely fundamental to, well, everything. They power our cars, they heat our homes, they cook our food. They are literally the engine driving not just our modern world, but life itself.
It's just such a great reminder that chemistry isn't some boring subject stuck in a textbook or a lab. No way. It's alive. It's in every single flame you see, it's in every engine, and it's happening inside of you this very second. So I'm going to leave you with a little something to chew on.
We've established that exothermic means releasing energy to the outside, to the surroundings, right? So, think about a campfire. Why does it feel so hot when the chemical reaction, the burning, is actually happening inside the log of wood? Think about that for a second. It's a great way to check if you've really got the core idea. Thanks for joining me on this one.